Hello everyone. In this series of Commutative videos, I have uploaded videos on solution of Commutative paper 2018 and 2019 of the mathematics topic. I hope you found them useful. If you have not yet watched them, click the link on the top right corner. I'm sure they'll be helpful. Also, for more videos on the 11th and 12th standard concept, hit the bell icon. Make sure you like the video and share it to your friends. Now, in this video, we'll be taking up questions on binary operation and binomial distribution. Let's discuss about binary operations. Binary operations are functions defined from the Cartesian product of a set to itself. For example, let's take the known binary operations. Addition is a binary operation. Suppose we take two different natural numbers and add them, our answer is a natural number. Okay, so what we have done, we have taken n cross n, that means two numbers, 3, 6, and our answer is 9, like that. So it's a binary operation. Addition is a binary operation on integers. It is a binary operation on rational numbers. It is also a binary operation on real numbers. But subtraction, if we talk about subtraction on natural numbers, the answer may or may not be a natural number. Take for example this 2, as we did in the earlier one. So this is not a natural number. That means subtraction is not a binary operation. On n, yeah, it is a binary operation on integers. Because when we subtract two integers, the answer will always be an integer. It is a binary operation on rational numbers. It is a binary operation on real numbers. So by binary operation, we mean that when we combine two elements of the given set by the operation, then the answer should be in the same set. So if we discuss about multiplication, because we know this, we will discuss about it a bit, so the idea will be clear. So if we discuss about multiplication, multiplication is a binary operation. When we say is a binary operation, we should just think that, okay, we are multiplying or we are taking two numbers and we are applying the operation over here, it's multiplication. Answer is in the set. If yes, then it is binary operation. Multiplication is binary operation on natural numbers. So every other superset, it will be a binary operation. If we talk about division, division on natural numbers is not a binary operation. Because if in case I take two natural numbers 3 and 2 and we divide it, it does not belong to n. It may or may not belong to natural numbers when we take two natural numbers and divide them. So it is not a binary operation. Okay, let's think about integers. No, it is not a binary operation on integers either. Okay, 3 and 2 are integers. Okay, is it on rational numbers? Let's take two rational numbers and think of their division. Suppose we take 3 as a rational number and divided by half. Our answer is 6. Yes, it is a rational number. If we take 3 and divide it by 2, it is 3 by 2. Yes, it is a rational number. But when it comes to 0, we have a problem. This is undefined. So division on rational numbers is not a binary operation. It can be made a binary operation if we change it to rational numbers minus 0. To the same set. Then even for real numbers, the same thing. If we eliminate 0 from real numbers, then it will become a binary operation. So binary operation means that we simply have to combine the two terms given the operation and the answer should come in the same set. And as we know, like we have been studying since so many years, the commutative law, the associative law, the identity element, and the inverse of addition, multiplication. So the same is for binary operations. Like let's discuss with addition first. Now we say that addition is commutative because when you take any two numbers and you add it in any order, the answer will be the same. It is also associative because we may take any two terms first out of the three terms and the answer will still remain the same. In addition, the identity element is 0 because when we add 0 to any number, the answer is the same number. The additive inverse is minus a because we get the identity element when we add the number and its additive inverse. So let's relate this to binary operations and we find that a binary operation is commutative if a star b is equal to b star a. It is associative if irrespective of the bracket the answer comes the same. We'll consider E as the identity element, then A star E is equal to A and is equal to E star A. So let's say A star B is equal to identity. Yes, it should be an identity element is equal to B star A. This is what we mean by inverse. B is inverse element A. We are not talking about inverse function. We are talking about an element there like minus a is the inverse element for addition. And same way, E is identity. Depending on the operations, the identity may or may not exist. And if they exist, it may vary depending on the operations. And same applies for the inverse. So with this concept, let's do a few questions based on binary operations. In good CET, generally identity element and inverse elements are asked, but once in a while they may also ask commutative and associative. So we'll take up questions of those kind also. In this question, we are just asked identity element, but we'll find both the elements, and this is a question which is asked many times, so we'll also generalize it. We know in order to find the identity element, we should take this law. Now, AB by 2 is commutative because whether you write BA by 2 or AB by 2, it is the same. So we'll just take this part over here and we see that instead of B, we have E. So from here we have E is equal to 2. And if in case we were to take this, our A was E and B is A. So in the same way, A would get cancelled, E is 2. So yes, the identity element is 2. Now looking for the inverse of the element. In this question, inverse is not asked, but we are taking up the inverse so that we can generalize and look for shortcut methods from the next question. So B is our inverse element according to this, and we know A star B is AB by 2. Now we have the identity element and we are looking for B because we have considered A is the element and we are finding its inverse, so we are looking for B. The inverse of A is B equal to 4 by A. That means if A is say 1, then B will be 4 by 1. That's inverse of 1 is 4. If A is half, the inverse of half is 8 because it will be 4 by half, so 8. So you take any positive rational number because that's the domain, you will get the inverse as 4 by A. So from here we can generalize that if we are given A star B is AB by N, then our identity element would be N and our inverse element, and you can say A inverse is N square by A. That's an element, okay? So let's see for the next question. Again, the same kind of question. A star B is defined by AB by 3 and we're looking for the inverse of A. Now we know the inverse of A for such questions can directly be written as 3 square by A. That is 9 by A. Number of binary operations on a given set. Suppose the set has, let's say the set is A and it has M elements. Then number of binary operations is M raised to N square. So in this case, it will be 2 raised to 2 square, 2 raised to 2 square, or 2 raised to 4, 16. So this is a general formula, you can apply it. Similarly, you can be asked a question like number of commutative binary operations. Number of commutative binary operations. The formula is n raised to n into n plus 1 by 2. So if the set has two elements, then the number of commutative binary operations will be 2 raised to 2 into 2 plus 1 by 2. That is, I've substituted n value because now we have n as 2. And so that becomes 2 cubed, that's 8. So you need to just remember these formulas. We need to find A inverse in here. So to find A inverse, first we have to find the identity element. That is A star E is equal to A. And for questions like this, just check whether it is commutative. If it is commutative, you need not do both the ways, like A star A and E star A, both of them. A plus B, yes, it is commutative. AB, commutative. Two numbers you add, again, yes, it's commutative. Do you get it? Here the operations are addition and multiplication, which we know are commutative. So A star B will also become commutative. So we'll simply go with only this much. Instead of B, put E. A plus E plus AE. We are finding E. That means our identity element is E. Now let's go for the inverse. Inverse means A star B is equal to E. What's A star B? A plus B plus AB. Once we have found E, for inverse now we are looking for B because B is the inverse of A. So B plus AB is equal to minus A. B common, so B is equal to minus A upon 1 plus A. Minus A upon A plus 1, inverse of the element A. In this question, you asked to find the identity element. So start with A star E and solve it and find the identity element. Now check every term, you're adding integers, which is commutative. So no need of finding equal to E star A. Just go for this and find the identity and put the answer in the comment box. Going to the next. It's a question similar to our A star B is equal to AB upon n. Here we said that when finding the inverse, we can directly write it as n square upon A. Now I want to find the inverse of 0.1. And what is our n? 100 square upon A. So that gives us option A. In this operation, we are looking for commutative associative property. So over here, first check, we are having two type of operations. One is multiplication and then we have addition, both of which are commutative. So this operation is commutative. So option D and B are not possible. So the thing we need to check is now associativity. So first we will look for general this and we can go for shortcut method. So putting in the bracket first, our A is B and B is C, we have BC plus 1. This is the first term and this is the second term. So going with the same, you can number this first term into second term plus 1. That's the method. First term into second term plus 1. Okay, first term, second term. So it becomes ABC plus A plus 1. What if we shifted our brackets? So this is A star B, which we can totally write from the question. And then we can use first term and second term thing. That is first term into second term plus 1. So that makes it ABC plus C plus 1. So that means it's not associative. It is commutative, but not associative. Now, because it is MCQ questions, we can go with numbers, but see that you don't take the first number as 1 because sometimes it comes out to be true for that. So let's take 2, 3, 4 as a number. Just avoid 1. So it is first number into second number. First number into second number. 12 plus 1. Again the same. First number into second number plus 1. 27 that is. Now shift the bracket. Do the same, first number into second number, 6 plus 1, that's how it is defined, 7 into 4 plus 1, first number into second number plus 1, 28 plus 1, 29. So yes, it is not associative. You can go with numbers for this being objective questions. So here are two questions for you to solve. Besides this, operations on sets are also binary operations. So we'll write down the identity and inverse for the same. And we also should notice one thing, that identity and inverse exist for only those operations which are commutative and associative, because we're looking for an element which satisfies this, an element in which A star B is B star A, an element where A star E is E star A. So, and we know union, intersection, and symmetric differences are commutative, so they will have identity element. If we recall, we know that given any set A, so that means our identity element is null set for union. Speaking about the inverse, we do have only this. For any other set, we will not get null set as the answer. So the only element which has inverse is null set, and that is the set itself. About intersection, A intersection universal set will give us A. That means universal set is our identity element. So when we are looking for inverse, our answer should come universal set. And that's again possible only for universal set, intersection universal set. So in this case, for intersection, the only element which has inverse is universal set, and it is the set itself. Now to symmetric difference. The identity element for symmetric difference is null set, because symmetric difference can also be defined as like A union null set minus A intersection null set, which is A minus null set A. The other case will be similar. The only thing is null set union A and null set intersection A. That means null set is the identity element. Now for inverse, our answer should come null set, and that's possible only for the set. So if I take A delta A, we're going to get A union A minus A intersection A. That is A minus A. That's null set. So every element is inverse of itself. This can be asked straight away as a question, like in symmetric difference, the identity and inverse elements for a given set are. So you can write the identity element or look for an option which is identity element is null set and the inverse of the set is the set itself. Because here A is an arbitrary set, it is any set of the given power set. Okay, like suppose it says sets on the power set of X, then A is any set in the P of X. So I think that pretty much covers everything about binary operation, which is important for good CT. Now we'll be going with the binomial distribution from probability topic. Binomial distribution is a kind of random variable which is associated with such experiments which have only two outcomes, or rather we say involved with Bernoulli trials. The characteristics of Bernoulli trials are that they have only two outcomes. One is success and failure. And when we repeat the trials, then each trial is independent. It can be repeated n number of times. Okay, so success, probability of success will be denoting with P and probability of failure will be denoting with Q. And as per our understanding about binomial, about random variable, we know that P plus Q, the sum of the probabilities has to be 1. And one more thing we will note here, that in each trial, the probability of success and failure will remain constant. It will not change. For example, if we toss a coin, first time, the probability that we get head is half, and the probability of getting tail is also half. If we toss the coin again, the probability will remain same. So if we're looking for head as the outcome, then success for us is getting ahead. So that's P. And getting a tail would be a failure. So P plus Q is 1, summation 1, and as many times we repeat this experiment or this trials, the probability of head will always remain half and that of tail will also always remain half. P and Q need not always be the same or equal, but they have to remain constant in every trial. So Bernoulli trials is associated with binomial distribution because they have only two possible outcomes, and when it comes to 2, it means bi, and that's why binomial distribution. So let's go with the formula of binomial distribution. It is P of x equal to, it is NCx, P raised to x, Q raised to n minus x. X begins from 0 up till n as many trials. So the success rate may be, or the probability of success may be 0 or 1 or 2, or every time we get success. Like if we have taken 5 trials and all the 5 times we get success. This is a notation of NCx, which is sometimes used in the paper. So I've taken that also. This is what we have been using in our regular study. So with the formula now, I think we are set to start with the questions of binomial distribution. The question is a die is tossed 5 times. That means we are taking 5 trials, and so our n is 5. N represents the number of trials. Getting an odd number is considered success. So let's say in a dice we know that we get 1, 2, 3, 4, 5, 6. As our outcomes, so the sample space. Odd numbers, success. So how many times do we get odd number? 3 out of 6 times. That is half is success for us. And we know for binomial distribution, P plus Q is 1. So Q is going to be half. The formula for variance is NPQ. N is 5, half, and half are the values of PQ. So it is 5 by 4. The formula for mean will be NP. And for a binomial distribution, the variance is always smaller than the mean. Okay, one more thing. How did we know it's a binomial distribution? The question says a die is tossed 5 times. We are doing the same thing 5 times. We are repeating the same trials. And odd number is success. So even number will be failure. Only 2 possible outcomes, and hence it is binomial distribution. So you're getting a defective whole is success for us, and that means P is 0.1. And Q is 1 minus P. The distribution of defective bolts in a total of 400. That means we are going to repeat this trial 400 times. N is 400. Formula of mean, NP. And formula of variance, NPQ. And I think that can be completed. So the mean is 40 and the variance is 36. Now it is the probability that a student is not a swimmer, and the probability that out of 5 students, that means we are going to look for whether the 5 students, each one of them is a swimmer or not a swimmer. So we have 2 outcomes and we are going to take 5 trials, so N is 5, and we want 4 swimmers. That means our success should be 4 times, that is X. 4 swimmers should be there. And what is the rate of success, or rather the probability of success? What is it? It is not a swimmer, means Q. See, we have been asked to find swimmer, and what is given? Not a swimmer. That means this is Q for us. So P is 1 by 5 because we know it is P plus Q is 1. The formula is NCx, P raised to x, Q raised to n minus x. In this question, x is given because we have been told we want 4 swimmers. So let's take x as 4. Yeah, put in the values and then calculate. So I'm taking a similar question. This is from NCERT textbook, and you will find a whole exercise of questions like this. That is exercise 13.5. So for more practice, you can do the textual questions from there. The question is find the probability of getting 5 exactly twice. So we want to get 5. So success is getting 5. And in a throw of a die, we get 5 1 out of 6 times. So that's success, probability of success. Failure would be probability of failure Q is 5 by 6. And how many times we are throwing the dice? We are throwing the die 7 times. So we have 7 trials and we are looking to get 5 exactly twice. So x is 2. Find P of x here. That's the formula. Put in the values. So that's a probability. I've calculated the whole thing because I'm not written the option. This is one of the subjective question from NCERT. So, but if it is in the good CT paper, similar question, you will have the option. So depending on the option, you can leave it in 5 by 6 form or these numbers or calculate it. Okay, so as I told you, you can do more questions from exercise 13.5. We were discussing, like, suppose if we are asked at least 2, then we would be looking for P of x greater than or equal to 2. That means we don't want 0 and 1. That's easier to find here, because otherwise it would be like finding P of 2, P of 3, P of 4, and P of 5. So better find 1 minus this. And yes, the formula remains the same. So first time you put x as 0, the next time you put x as 1. If it was at least once, then it would be at least one success, I mean. Then it would be 1 minus P of 0. It were to be at most 2, then it has to be P of 0, P of 1, and P of 2. These values. Okay, so you individually calculate this and put in the, as per the option you will have to look for. Okay, so these were questions on probability. I mean the binomial distribution thing. So here are 2 more questions on binomial distribution. With this video, we come to an end of the series of good CT papers and topics. However, during the good CT paper, that is on the day of your exam, you have time after the first paper, so you can revise the topics with the help of the videos. If you have not seen any or any topic you would like to revise, you can go through the video once again, and that may help you. So best of luck for your exams, all of you. God bless you. Thank you.